So in our last video, we were looking at congruence modulo m as a relation. And in this video, we're going to look at some properties of that congruence relation and a little bit of arithmetic that can be done with it. So here are the properties we're going to write down. Properties of the congruence modulo m relation. So number one, an integer a is always congruent to itself. We said that before, mod m. This one, if you've taken Math 299, you would have heard this called the reflexive property, or reflexivity for short. Number two, if an integer a is congruent to an integer b mod m, then b would also be congruent to a mod m. If you've had Math 299, you would have heard this one called the symmetric property, or for short, symmetry. Number three, if an integer a is congruent to an integer b mod m, and an integer b is congruent to an integer c mod m, then the result is, the conclusion here is that a is congruent to c mod m. If you've had Math 299, you would have seen this, and you would have called this probably the transitive property, which we'll just call for short transitivity. This is all stuff that you would prove in a Math 411 class, Intro to Modern Algebra. You'll prove these things using the definition of congruence mod m. We're not going to prove in this class. This is not a proof class. So also we can do arithmetic. If a is congruent to b mod m, and c is congruent to d mod m, then you can do addition between these congruence relations. So if I take a and add it to c, that's going to be congruent to b plus d mod m. Now basically, if I add the left-hand sides of the congruence relations a and c, then that's going to be congruent to the right-hand sides, b plus d. So you can do this kind of almost like equations, where you add equations, you can add congruence relations. Number 5, you can do a similar thing with multiplication. So if I have a is congruent to b mod m, and c is congruent to d mod m, then if I multiply a times c, that's going to be congruent to b times d mod m. As far as proper names given to these, number 4, we could say addition mod m is well defined. That's a title for this property, number 4. Addition mod m is well defined, and number 5, multiplication mod m is well defined. So some names for these properties. All right, so we want to do a little bit of arithmetic involving the congruence relation. So I'm doing exercises. Suppose you have integers a and b. Suppose a and b are integers. A is congruent to 5 mod 17. So here we're not told exactly what a is. We're not told a is a particular number. We just know it's congruent to 5 mod 17. And we're also told something about b. B is congruent to 7 mod 17. We don't know exactly what number b is, but we just know it's congruent to 7 mod 17. So what we want to do, we want to find the integer c with the following property. C must be between 0 and 16. So it's allowed to be 0, it's allowed to be 16, but it's also could be in between those. So C is not allowed to be negative, and C cannot be 17 or more, such that the following happens. Let's do a number 1 here. Number 1. So we want C to have this special property. It's congruent to 5 times A mod 17. Okay. Now, based on our properties of modular arithmetic, I can do basically a replacement. I can replace A. So even though A is not equal to 5, here, let me highlight my two special givens. I have A is congruent to 5 mod 17. I have B is congruent to 7 mod 17. So even though A is not equal to 5, it's congruent to 5, I can still replace that A with a 5 based on my congruence property. So here I'm going to have, let's see, I'm going to have C is congruent to 5 times. So in place of A, I'm going to put a 5 here. And remember, we're mod 17. So all I've done, I've replaced the A with a 5. So what do we have? We have C is congruent to 25 mod 17. Now, we don't know that C is equal to 25. We just know it's congruent to 25 mod 17. Is C allowed to be 25? No, it's impossible, because we know that C has to be between 0 and 16. And yeah, it could not be 25, because 25 is outside of that range of values. So what are we going to do to find exactly what C is? Well, we're going to use the division algorithm. The division algorithm. So here I come over here on the side, doing the division algorithm. I'm going to take the number 25, which C is congruent to. I'm going to divide it by the modulus, 17. I'm going to get a quotient plus a remainder. And my remainder is actually going to be the value of C. So let's find the quotient here. So 25 divided by 17. Well, 17 goes into 25 exactly once, right? It has a remainder of 8. So my quotient is 1. My remainder is 8. So that means C is congruent to 8 mod 17. And because C is congruent to 8 mod 17, and 8 is between 0 and 16, right? You have to make sure your C is between 0 and 16. That means C is actually equal to 8. So my C is actually 8. All right, let's do another example. Number 2. Here I have C is congruent to 31 times B mod 17. So I'm going to start with C is congruent to 31. And remember that B was given to be congruent to 7 mod 17. We don't know if it's equal to 7, but we know it's congruent to 7. So we can replace that B based on our properties of congruence arithmetic with a 7. Replace the B here with a 7, and this is mod 17. So I have C is congruent to, what is 31 times 7? Well, I believe that is 217. Right? 217. So C is congruent to 217 mod 17. Now, remember, the number we're trying to find, C, is congruent to 217. It's not necessarily equal to it. Could it be equal to 217? No, because C has to be between, remember, 0 and 16. So to find exactly what C is, we're going to use the division algorithm and look at the remainder. So I'm taking 217, I'm dividing 17 in it, I'm going to get a quotient plus a remainder. So let's see, how many times does 17 go into 217? So 217 divided by 17 is 12. And we're going to take 217 minus 17 times 12, and we're going to get a remainder of 13. So quotient is 12, remainder is 13. So what does that mean? That means I've subtracted, so okay, I got C is congruent to 13. Let me just write that down before I say anything else, mod 17. So how did I get from C equals, C is congruent to 217, from C is congruent to 217 to C is congruent to 13? How did I go from the red to the blue? Well, I basically subtracted 17 12 times. So I started with 217, I subtracted 17, 17, 17, 17, 17, 17, 17, 17, 17, 17, 17, 17, 17, 12 times until I got down to 13. That's what's actually happened. And notice that 13 is between 0 and 16. So 13 is our correct number. So C is not just congruent to 13, it's actually equal to 13. All right, let's do one more. Number 3. We have C is a number that's congruent to a to the third power minus 3b mod 17. Now here's a question. Are we allowed to do exponentiation and doing modular arithmetic? And the answer is yes, because really exponentiation is just multiplication. How is exponentiation multiplication? Well, remember, exponents are just repeating multiplication. When I say a to the third, that means I'm just multiplying a times a times a. So in reality, a to the third is just multiplication by a multiple times. Okay, so here we have C is congruent to a cubed. Well, we know that a was congruent to 5, so we're going to put a 5 in there in place of a. Minus 3 times, what was b congruent to? B was congruent to 7. And this is all mod 17. So I'm going to do this arithmetic. We know C is going to be congruent to, let's see, 125 minus 3 times 7, 21, mod 17. You know, C is going to be congruent to, I believe, 104 mod 17. Right? 125 minus 21, I believe, is 104. Now, 104 cannot be your actual value of C, because remember, C has to be from 0 to 16. So to find the value of C precisely, we're going to use the division algorithm. So I'm going to take 104 and divide 17 into it, get a quotient, and my remainder will be my answer. So how many times is 104? Or sorry, how many times does 17 go into 104? 104 divided by 17 is 6. So I'm going to take 104 minus 17 times 6. I'm going to get a remainder of 2. So my quotient here is 6. My remainder is 2. So my C is congruent to 2 mod 17. So how did I get from 104 to 2? Well, I subtracted 17, my modulus, 6 times. So I took 104 minus 17, minus 17, minus 17, minus 17, minus 17, minus 17. I got down to 2. And 2 has to be the value of C, because C must be between 0 and 16, and 2 does the job. So C is actually exactly 2. All right, so we will stop with these modular equations, and yeah, we'll do some practical stuff involving modular math using clocks.